Hi there everyone, it's Malcolm Boudin here from MNB Networks. Today we're going to go back to basics and talk about physical WAN to LAN handoff. This is a slightly different subject matter and it might not be as regarded as interesting as some of the other things that we've done, like software defined data center, software defined LAN, WAN, etc., but it's equally as important. So let's just jump right in and build out a scenario based on design and look at a couple of different things. So today we're going back to basics and concentrating on physical infrastructure. And what do I mean by that? So a lot of the stuff that I do is focused on wide area networking, but I also like to consider the wider picture, and when you're refreshing a wide area network, one of the things that's more important than ever now is to understand how the local area network is going to integrate with that, especially when we're moving into the SD-WAN world with segmentation, policy or application policy based routing and things like that. A big part of the SD-WAN being a successful project is going to be that the functionality that you implement in the wide area network can be transposed or handed off so that we can provide an end-to-end service and capitalize on the wide area network in the middle. So part of that is going to be where you have a wide area network device, whether it's WAN, and this applies to SD-WAN and traditional WAN. You have to think about how are you going to actually hand off over to the local area network. Because if you have something like old unmanaged switches which don't really provide any sort of functionality, or even if they do but they have no configuration on them and they've potentially been installed out of the box, you might have a whole myriad of issues that you need to troubleshoot after you implement the solution, or you might have things that you need to do as a prerequisite in order to support the new solution. And that might either just be a configuration thing or it might be an upgrade of a existing solution. So let me start drawing some stuff in here. We're going to draw in, first of all, this is our wide area network. So forget about how it actually runs. What we're going to concentrate on is we're going to draw 5 different sites or site types, and we'll work through them one at a time from basic to a little bit more complex. And this is based mainly on the physical side of things. So if we start on site type 1, and this is your WAN connection, okay, we have a WAN link, let's just say that's 1 gig, which is kind of irrelevant, but it's just to put some stuff in the photo, or the picture I should say. This is the WAN appliance, so let's call it the CE, customer edge. The first one is very simple, okay, so let's say we have a LAN switch here, and we might have like 1 VLAN, for example, and we can have the default gateway on here, or we can have the default gateway up here, or we can have a routed link like this. And this pretty much applies to every single design that we talk through, but remember today we're not concentrating on the logical layers, we're talking about the physical layers. So let me just take that stuff off just to avoid any confusion in the picture. What I'm going to do here is zoom out a little bit and just create a key. So what we're talking for the purposes of this video, a blue line is a 1 gig and a red line is 10 gig. Now, the actual handoffs that we talk throughout this presentation, it could be 1 gig, 10 gig, 100 meg, but those are the most typical types of, or speeds I should say, that people are handing off the WAN to the LAN. And I guess it really does depend on what speed you have here. But by the same token, you might have a global standard of where you hand off from the WAN to the LAN globally, where there's a 10 gig a 10 gig connection available, you use that for whatever reason. Okay, so let's not dwell too much on the details about that just now. So let's talk purely about physical connectivity. In this first site, we're just going to explain something very simple where we have a 1 gig physical link which connects in from a single router into a single switch. It doesn't really get much more simple than that, and I don't think there's even much that we really need to say on it other than point out obvious things like we have a single point of failure here, we have a single point of failure here. However, that might be perfectly adequate because if we have users connected to this site, which have a laptop or whatever, normally on these types of very small sites, if something fails, you know, here or further up, then you can tether to a mobile phone and then hit the internet and then get to your WAN this way. Okay, so that's a concept again that can be applied anywhere. It's not just one single site type. So I'm going to categorize that as a physical one, you know, and we basically, it could be copper, it could be fiber, multi-mode, single mode, whatever it fits. But the point here is that we have a single router, a single switch, and we hand off with a single link. So that's, let's say that's number one. Number two that I want to talk about might look something like this. So we have our WAN link with a single router. Then we might have a switch stack here instead of a single switch. So what do we then do? Okay, we have a couple options. We're going to go with a 1 gig handoff again. So I'm going to draw a line down here where this is a fiber or a copper or whatever it is. So it could be fiber, multi-mode, single mode, could be a copper if it's just a short distance within the same comms room, for example. So we have another link which comes down like this and connects into the second switch. So if these switches, if that's switch 1 and that's switch 2 in the switch stack, and if you're not familiar with switch stacks, you're new to the industry, a switch stack is where a LAN switch is connected to another LAN switch and they operate as a single LAN switch. So we have a couple of options here where the reason that we connect into different LAN switches is so if this one fails, for example, and this effectively becomes unavailable, then we still have connectivity via the second switch in the stack. Some of the options that we can look at here are we could potentially, because we are using a single switch stack, if this is 2 times 1 gig, this is a common way of illustrating a port channel where we put this oval shape and that effectively makes 2 gig link aggregation or lag, but it's a 2 gig aggregation. So basically we have if I go back to the purple pen, we have a single device here, we have 2 devices but they operate as one device because they're stacked, and then we have as illustrated by the 2 blue lines, we have 2 times 1 gig, but they are aggregated as a single 2 gig circuit. So it provides redundancy, it eases configuration because we don't have 2 separate switches to connect to from the switch stack perspective. But there is some other trade-offs there that we might want to think about, i.e. sharing the control plane between 2 separate devices, but that's probably something for another discussion, or another day, I should say. So, in summary, as I say, single router handing off to redundant switches. Some of the things that you might want to think about in here is this physical on the left and this physical on the right. You might want them to be in different slots. So this might be in slot 0 of the WAN router, and this one might be in slot 1 of the WAN router. So that's just thinking, again, we're thinking about physicals here and what could fail. How do we fail over? Things like that. Now, let's move to scenario 3, or physical handoff 3. This time we're adding a little bit more complexity into the situation. So we have two routers, okay, and they have their own WAN links. They might be then connected together, and similar to scenario 2, we have a switch stack. Just to confirm, switch stacks can normally have up to about 8 or 9 switches in the stack, but I'm only showing 2 just to simplify the explanation. Now, let's talk about how we hand off from two routers into the local area network from the wide area network. The routers in question, of course, are up here at the top, and what we could do, this again, these are just options, and everything is going to be relative to your own environment depending on what you're able to do within your environment, and that might be from a physical perspective or it might be from a standards perspective. So you might only be allowed to do certain types of handoffs. Now, when we have this type of scenario, we've got pretty much the same thing as we had in number 2 over here, but we have 2 routers instead of 1. So we have the same methodology, the only difference being that we can't, or we cannot really provide the same type of port channel handoff unless those 2 routers were part of the same system. And typically routers which hand off to the WAN, traditional routers, are not really capable of doing that. That said, SD-WAN appliances are normally capable because they more operate like firewalls, and they can operate in active-active or active standby mode. But let's just assume that we're talking about traditional type networking and networking devices, and these 2 routers can only operate independently of each other. So in that scenario, we have a couple of options. We can either do what we have here, or we can double up on our connections, but sometimes this might be overkill. So we might, have the routers connecting into both switches, and then we can potentially do a port channel here and a port channel here, so it looks like two single connections. So it's actually four physical connections, but we could potentially bond them to look like 2 separate physical connections. But we're not going to do that in this scenario. We just wanted to talk about what you could actually do. So how do we then move forward from this? So we could have the default gateways up on the device, well, down on the switch level here. So if the purple is the default gateway, and then you've got LANs here, or you could have the default gateways here and here, and then that would have a floating HSRP or a VRRP address, and then just a static default route up to the floating address. So those are a couple of things that you maybe want to think about, but hopefully this is building up a picture for you to see that your choice in physical design is going to have a big bearing, or at least some bearing, on what you do at the upper layers at the physical side of things. So that is physical handoff number 3. Now let me zoom out because I need a little bit more space for this one. Probably should have drawn it across to the left a little bit. Our next scenario is similar to scenario 3, where we have 2 routers, and what changes now? We still have the link between the 2 routers. We still have a switch stack between 2 routers, but we then might want to have 10 gig links. Now let's talk about how that changes things, if at all. So red is a 10 gig link. If this was if these were SD-WAN appliances, they would effectively be clustered like this. And it doesn't just have to be SD-WAN appliances, it could be firewalls, which many of the SD-WAN appliances and firewalls that are coming out into the marketplace are actually firewalls which have had SD-WAN capability built into them, you know, whether that's through an acquisition or built from the ground up like that. So if we do have that functionality though, and let's say we have like active, so that's active and that's active, we then are presented with an option if we want to do something like this. So we have physicals into both devices, and we also have a switch stack here. So the routers operate as one device and the switch stack operates as one device. In this scenario, we could potentially create 40 gig, or if that was blue, 4 gig. And we only have one logical link, which is this circle that we've handed off from the WAN to the LAN. So you see here, and then when we start getting into 40 gig handoffs, and when you think about the upper layers, that's where you really need to think about like things. If, for example, you run OSPF in here between the WAN to the LAN, then that's going to have a knock-on effect to the costs and the reference bandwidth and things like that. And yeah, so there's things that you really need to think about there. Let's knock that on the head. So the key point here is that if you have clustered routers and a clustered switch which you're handing off to, you're able to then potentially do link aggregation or a port channel across all of the links which hand off between the WAN to the LAN. So that's the 4 red links which go into switch 1 and switch 2 in this scenario. Oh wow, I've not even connected these to the WAN yet. Right, so we have one more scenario to talk through, and I'm going to draw that in now. This gets even more complicated. So, or a little bit more complicated, I should say. So let's say what changes here, right? This is more, we're talking about a legacy. Let's say you're implementing an SD-WAN solution, but what you're handing off to the LAN is some sort of like legacy design. So this is still 2 separate switches, but they're not clustered this time, or they're not connected together. So from the LAN perspective, you might have a default gateway here and a default gateway here, and then some sort of VRRP or HSRP down here. Now, how does that affect the physical handoff? Let's talk about it. So if we have 2 routers, one router here and one router here, what do we really want to achieve here? There's many different ways that we can actually look at doing this, but I'm just going to illustrate one way. So we're 10 gig again for this scenario. So let's get a couple of 10 gig. Let's really beef this network up. We've got a couple of 10 gig capable routers, and we first of all we know that we need to connect the physical infrastructure to both of these switches. So if this is switch 1 and this is switch 2, but they are these are independent of each other. So these 2 are independent of each other. So then what do we think about? We have to think about the failure scenarios. These are both connected into the wide area network as well. They have their own WAN links. Forgot to actually mention that was scenario 4, but hopefully you knew that. And we're now on scenario 5. So those are connected into the wide area network, and we're now thinking about how do we need to hand off. Now, there's a few different things for consideration here. This link or these links between, you know, the router 1 and router 2. So there's router 1 and that's router 2. And we need to consider the handoff. We can either have these as potentially 2 times ECMP links. So again, this is thinking a little bit higher up the layer, or the layers, I should say. So we could have 2 times ECMP, or we could have 2 times IBGP. They could be port channeled. When I say 2 times ECMP, I'm talking like OSPF, for example. But you might run OSPF with BGP on top. That might be a port channel, which could be layer 2 or layer 3. Whoops, layer 3. And it's these links down here that we're talking about. So that's probably the first thing. How are you going to interconnect these? Truth be told, or well, maybe not truth be told, because every design is different, but something, or the thing that I would normally see is either this would be represented as, oops, let me just rub these out for a second. These links between the actual routers, normally you really just want them to be seen as one link. So that's either going to be a physical or a layer 3 port channel. Where it's basically 2 links that are aggregated. Now, then we have the challenge of how do we hand off to the lower layers. So when I say the lower layers, I'm talking about this part here, because we need to make a decision around this on how much redundancy we want at the physical layer. So let's look at our options. We can put a link like that and a link like that, which would give you what you would probably expect to see in most scenarios. But if you also wanted on box redundancy, so let's say if line card fails inbox redundancy, and in order to achieve that, it's similar to what we talked about in one of the earlier scenarios, where if you, in scenario 2, where if you look at the purple lines, which were down here, the 2 purple lines, we talked about line card 1 and line card 2 in the single router. So we would apply the same concept here, where we would have, this would be in line card 1, and that would be 1, and that would be 2, and then you might have another link like this, and then you have like a port channel here and a port channel here, and then a port channel here and a port channel here. So this loop, you can see this is getting really like complicated. So what I would suggest that is adequate, and from the most of the CCDE study that I done, or the discussions that I had, and we done redundancy to death, the sorts of things, well, not the sorts of things, the conclusion that we kind of reached was 2 is normally good enough, and anything more than 4 from a physical perspective is probably over complicated. So I think in this particular scenario, what you see here with a link between the 2 routers, which might be like a layer 3 port channel, a good candidate for a layer 3 port channel, and then effectively 4 separate handoff links from the WAN to the LAN is probably adequate, because if you think again to the higher layers, you're probably talking about potentially things like VRFs being handed off, multiple routing processes if it's OSPF for each of those VRFs across multiple links. And then if you're, let's say it was a 10 or a 40 gig link, in this scenario it says it's a 10 gig link, so you're probably going to have to then start playing with OSPF costs, reference bandwidth, and all the rest of it. And that, for the sake of redundancy, you might actually be better plugging in a second cable but not activating it. So if the line card failed, then you might just bring that port up and shut the other port down, assuming that you can still get to the devices. So if I zoom out here, you can see that we have effectively 5 different models of physical handover from the WAN to the LAN, and this, I would imagine, is probably not all of them. So when I say it's back to basics, which was the title of this presentation, you can see that even the basics in networking require a lot of thought. I hope that's opened your mind and opened your eyes, hopefully a little bit, as to what's considered or needs to be considered in physical network design. Going into the new world of SD-WAN, SD-LAN, this is not just for WAN to LAN handoff. You have to think about, imagine you had a campus network with 2 or 4 core switches and 20 or 30 distribution blocks with another 10 to 20 access layers, and then they were all connected at 10 gig, for example. They were routed access with VXLAN overlays, or they might be the traditional distribution switches, core switches to a distribution switch, which then has multiple, and there might be multiple distribution switches with multiple access switches coming off it in what you would, I suppose you would call, is like a large campus design. So this is all focused on LAN and not really the objective of this video, but I hope you enjoyed it. If you liked it, please let me know by leaving a comment, leaving a like, and subscribing to the channel or MNB Networks LinkedIn, Twitter. Connect with me, Malcolm Boudin. I'll be happy to on LinkedIn, Twitter, etc. Take care and speak to you soon on the next video. Thank you.